This is 2007 AIME I Problem 8. So we're told the polynomial p of x is cubic, and then we're asked what is the largest value of k for which the polynomials q1 of x, which is some quadratic, and q2 of x, which is some other quadratic, are both factors of this cubic p of x. Okay, so what this problem statement is implicitly telling us is that if you take q1 of x and multiply it by some linear factor, and q2 of x and multiply it by some other linear factor, you're going to get this cubic polynomial p of x. So what we can do then is set q1 of x times some general linear factor equal to q2 of x times some other general linear factor. And that's going to look like the following. So we have q1 of x times some factor ax plus b is equal to q2 of x, or q sub 2 of x, I guess I should say, times cx plus d. Okay, and once we do this, we can equate coefficients, and then we can actually get a system of equations in order to solve for k. Okay, so what we have is x squared plus k minus 29 x minus k times ax plus b equals 2x squared plus 2k minus 43 x plus k times cx plus d. Okay, so now let's group similar coefficients. Okay, so first we have ax cubed is equal to 2cx cubed. It's pretty easy. Now for the quadratic terms, let's see, we have bx squared, and then we also have a times k minus 29x squared. So that gives us b plus a times k minus 29 x squared, that's all attached to the x squared, is equal to, on the other side, 2d plus c times 2k minus 43 x squared. Now for the linear terms, we have b times k minus 29, then we also have a minus, or sorry, we have, minus ak. X is equal to, on the other side, we have d times 2k minus 43, and then we also have plus ck x. Okay, so those are the kind of the messier equations, and I'll also label them after when we get rid of the terms. And then we just have negative bk is equal to dk. All right, so let's just get rid of all the unneeded variables and turn this into a nice system of equations. So we have a equals 2c from the first one. We have b equals negative d from the last one. And then the other ones are not quite as nice. So we have b plus a times k minus 29 equals, let me make sure that's right. Okay, equals 2d plus c times 2k minus 43. And the last one is b times k minus 29 minus ak is equal to d times 2k minus 43 plus ck. Phew, okay, so we have all of our we have all our equations written down for the system. Okay, so the easiest way to go here would probably be to just make substitutions into equation 3 using both equations 1 and 2 simultaneously. So that's what we're going to do. So let's rewrite equation 3. So we're going to we're just going to get c and d in equation 3. So we have negative d plus a, which is 2c, times k minus 29 equals 2d. We don't have to change anything on the right side, plus c times 2k minus 43. Okay. So then we have, let's see, we're going to have a 2ck on this side and a 2ck on the other side, and there aren't any other ck terms. So we can actually just get rid of the 2ck's preemptively. And then we're going to have negative 58c minus d equals, let's see, negative 43c plus 2d. Okay, that gives us 3d is equal to negative 15c, which means d is equal to negative 5c. All right, that's a very nice result. And now we can actually go ahead and substitute, or make a couple substitutions into equation 4, which are going to allow us to solve for k. All right, so we're going to turn b, so b is equal to negative d. Negative d is equal to 5c. So we actually have 5c times k minus 29 minus, we're just going to leave a as 2c, so minus 2ck. And then the other side we have d, which we're just going to turn into negative 5c times 2k minus 43 plus ck. Okay, now take a careful look at these factors. What each of the terms have as a factor on each side? That's right, they all have a c. All of the c's go away awfully conveniently, and we're left with just k terms. So now we have 5k minus 145 minus 2k equals negative 10k plus 215 plus k. So then over here we actually negative 10k and k, that turns into negative 9k. Over here we have 3k, so we have 3k minus 145 equals negative 9k plus 215. Solve that down, we get 12k equals 360, so k must be equal to 30. And that's it.